Okay, so when you hear this word intermediate, what do you think of? Middle, medium, beginner, the absolute beginner. Like if you're in intermediate school, you're in between elementary and high school, you're somewhere in the middle. So I like that, but I don't want you to think this means exactly in the middle, like the point. This just means somewhere in between. Somewhere in the middle, but not the exact middle. Okay, that's what I want you to think of when you hear this intermediate value theorem. Okay, so this is what the intermediate value theorem is, and we're going to go ahead and do a theorem write-up tomorrow on this. I'm not going to do that part today, but this is the theorem. So I'm going to kind of unpack this piece by piece. So we have a function f, so it has to be a function. Anytime you see f, that implies function. It's continuous. What has to be true in order for a function to be continuous?
No holes, jumps.
No holes or jumps. What were the three rules? Limit exists, point exists, and they're the same. Okay, so that has to be true in order to even use this. On AB, AB is an interval. So I'm going to go ahead and start this picture down here where I have an x value of A and I have another x value of B. So the intermediate part is going to be happening between A and B. And let's go ahead and draw a function too. It doesn't really matter. It doesn't have to be increasing. It can be decreasing. And you could even draw a parabola where it goes up and comes back down. Any of one of those will work. So then this says, and k. Okay, we'll come back to this because I don't know what that means yet. It's any number between f of A and f of B. Okay, so if A is the x value, what is f of A? It's the y value that represents the y value at A. Okay, and so we have the same thing happening at B. And so now we can kind of come back to K. So f of A and f of B, these are both y values. So if K is in between them, what does that tell you about K? Is it x or y? It's a y value, and it's somewhere between. So you can go anywhere you want in between here. It doesn't have to be the exact middle. So I'm going to put mine right there. So I'm going to put K, and I'm going to go ahead and go over here, and I'm going to plot the point where the y value is K. And then look at the x value at that point. It's between A and B. This is what intermediate value theorem states. And it may seem kind of obvious to you, and that's okay if it does. That just means it makes sense. So we're saying that if you have a continuous function, all right, and you stick a k value in between the two y values, your x value has to be between A and B, or there has to be at least one. So even if you made this become a parabola, there could be, maybe be more than one, but there's always going to be at least one. And we call it C because it says here f of C equals k. That means that C is the x value and k is the y value. That point has to be there in between. And again, if this is obvious, that's a good thing. Okay, so why would we even have this theorem? What good is it? So first of all, if you have this theorem, you can use it to locate zeros. What are zeros? Solutions, roots, x-intercepts. Those are kind of a big deal. You've been told to find those a lot in your math classes before, and that's because we use them a lot in calculus. So this is going to be able to tell me that there's at least one zero. So let's look at this. If f is continuous on AB, that's the same thing that happened last time, and f of A and f of B differ in sign. What this means is that one of the y values is positive and one of the y values is negative. It doesn't have to be f of A is positive. Just one's positive, one's negative. Then there has to be at least one zero. So the way this works, I'm going to draw this over here. So we'll say here's f of A. And then down here would have to be f of B. And so wherever your 2 points are, I'm going to make this one a decreasing just to show it. if I connect those 2 points, what must happen? I must cross the x-axis. That's how you get a 0 there. So if we know our 2 endpoints, we can find then the y values. If one of them's positive and one of them's negative, then I'm guaranteed to have a 0. So that's what they're asking us to do in number 1. Use the intermediate value theorem to show that this function has a 0. All we need to do is find, and they're giving us, this is our a and our b right here, 0 and 1. So we need to find f of 0 and f of 1, and we're looking to see if one's positive and one's negative. So go ahead and do that. Plug in 0 and plug in 1 and see what you get. Okay. So I know I didn't give you a whole lot of time for that, but hopefully you got negative 1 and 2. One's positive, one's negative. All right, so this is our work. You see this word show? That's kind of like a slang word for prove. So we've got to make sure we write out what we need, because this wasn't asking us if there was one. We can't just say yes or no. We need to show it. Okay, so all you got to do is really simple. Put the negative 1, put that it's less than or equal to 0, put that that's less than or equal to the positive 1. By doing this, you've shown that there is a 0. Okay? We're good to go. We could write it out more in sentences, but this is the part that I want to see for right now. Okay? If we were doing a formal proof, we'd have to do a little bit more. All right. Problem 2. Okay, problem 2 says verify. Verify is one of those words again. It's not really a formal proof, but we're going to have to maybe show more than just maybe what you're thinking in your head. So verify that the IVT, intermediate value theorem, applies to this interval and find the value of c. So there's 2 things. We've got to prove that it's working, and we've also got to find the c value. So again, they're giving you an interval. Every time they give you an interval and they're talking about intermediate value theorem, you need to find f of the a value and you need to find f of the b value. This one's a little bit harder. Okay, so we could do this by hand, or you could use your calculator. So go ahead and pick whichever one you want to do. Which one you think's easier and do it. And you can do this in your head, you can do this on the calculator. I'm not going to go over the number crunching part of 5/2 today. So I'm going off of memory, so I want you to look up here and check. Whichever one you did, check to see that I got it right. Because I might not have remembered it correctly. I'm not pretending like I can do math like that in my head that fast. Maybe the 4 one. F of 4 wasn't too hard to do in your head. Okay. Are we good? So the next thing we got to figure out, okay, is 6 somewhere in the middle. Now, which of these 2 is smallest? The top one, right? 35/6. Is this less than or equal to 6? Yeah, because 6 is the same as 36/6. So 35/6 would be less than. Okay, now we got to figure out, okay, is 6 less than 20/3? Yes, because 6 would be 18/3, which is less than or equal to 20/3. And some of you might have done the decimal on this, but if you can stay accurate with the fraction, do that. Okay, so that took care of that. Yes, intermediate value theorem applies to this interval. Now to do the next part, it's a little bit more work, okay? When they say f of c equals 6, this 6, is it the x or the y? It is the y. The c part, that's the x. Then what it equals, that's the y. So when I look at my equation, x squared plus x over x minus 1, this should equal 6. And what I'm looking for, I could have written c here instead if I wanted to, but what I want to know is, okay, well, what does x equal? Okay, so tell me, how would we do this without the calculator, just words? What do you think? So we could cross multiply, and then we'd have a quadratic. And how could we solve a quadratic? We could factor or use quadratic formula. So it's not that bad to do. I'm not going to do that today. I want to look at the calculator. So if you want to follow along with me, feel free. Now I've already typed this in, so I kind of got to head up on it. But you're going to have to be pretty wise with parentheses here. Now remember that when you type it in, you're going to go to F2, which is your algebra, and you're just going to pick number 1, which was solve. And even when I was typing this in, I forgot one of my open parentheses, so I had to go back and put it in. The reason I need so many is because I need one around just the numerator, okay, like this if we were looking at it. I need some around the denominator. Then I need some around the whole thing, and then remember we had that whole equals 6, and then comma x. Don't forget about the comma x, and then there's just a parenthesis after this. And then we press enter. And so you should get x equals 3 or x equals 2, and you would get the exact same answer if you factored and all that. Yeah, the comma x says solve for x, which seems obvious here, but later on we're going to maybe use it for multiple variables. Yes?
Calculator saying it says too few arguments.
So too few arguments. Did you do equals 6?
Oh, that's why. How do you clear the letters?
F6. If you hit F6, which is really just second F1, it should give you the option clear A to Z. And you do want to do that because you want x to be x. You're solving for x. If something is stored in for x, you don't want that.
Oh, you could. Okay, I see.
And this is only if something was stored in for x. If nothing's stored in for x, then you don't have to worry about that. So you don't have to do that every time. Okay, so we get 2 answers, which is totally fine because the theorem didn't say there was exactly one. It just said there was at least one. Okay? We good? The calculator is getting a little bit better? A little bit easier to use? Okay. All right, let's turn it over on the back. And we're going to kind of use intermediate value theorem on this problem, but I'm also going to start teaching you about these tables. So I'm given a table, and I'm given my x, and then I'm given f of x, g of x, and then down here, I'm going to talk about h of x. All right, so I even have a third function. So they give me what I need to know. They tell me that f and g are continuous. They also tell me that g is strictly increasing, which may not seem like a big deal, but it's good to know. And then it said, but although we could kind of see it here, but this doesn't give us all the values, it just gives us these 4. And they give us the table. So they want to know, okay, if we have this new function where we take f of g of x minus 8, that's our new function, explain why there must be a value s for 1 less than s less than 3. Now keep in mind, remember before how we saw something like this? That's the same thing, but really in this case it would be parenthesis, not because it's a point, but because it's an interval. And that's the most confusing thing about interval notation is that it looks like a point sometimes. But this right here is the same thing. So remember how we did f of 1 and f of 3? Well, now we're going to do h of. Okay, so let's go ahead and write this over here. H of 1 and H of 3. Yes.
So if it was 1 less than or equal to s less than or equal to 3, would that be the brackets?
Yeah, if there were or equal to's here, you would have brackets. And really, for all purposes, for what you're doing, it really doesn't even matter whether there's brackets or not. It just has to do with maybe 1 or 3 could be included or not included. But you're still going to do it the same way. So let's start with h of 1. And all I'm going to do is plug it into here. So I'm going to do f of g of, my x value is 1, minus 8. So I need to go up here and I need to find g of 1. G of 1 happens to be 2. So I'm just reading the table. When x is 1, g of x is 2. So that's a 2 right there. So let's plug it in. I don't think it's wise to do all these steps at one time. It gets confusing. Okay, now we're going to go and look it up what f of 2 is. So I find x equals 2. The f of x is 9. And 9 minus 8 happens to be 1. Okay, so that's my first y value. So I want you to go ahead and go through and find the other y value. Find h of 3 and just do it step by step like we did before. Okay, so what did you guys get? Those of you that have finished.
That's the final answer?
Yeah.
Negative 9.
Negative 9? Everybody? Okay, so what was g of 3?
4.
4. And so then you're looking up what is f of 4, which is negative 1, and negative 1 minus 8 is negative 9. Okay, so I'm going to circle these two values. These are my two, 1 and 3 were my two endpoints on my x-axis. Negative 9 and 1 are my two y values. Okay, so really, when it's saying explain why there must be a value for s, all you're really looking for is negative 5 in between these two numbers? Yes. So let's show it. And we could write more, like I could write down here that this is really h of 3 and this is h of 1 and all that. But we already showed all the work up here, so we just need to top it off. And I did go ahead and because these are less thans, I just used less thans here, and that would be appropriate. If you put or equal to's here, it wouldn't be the worst thing, but I would say just follow suit.